Hi, everyone. Welcome to today's live broadcast, where we're going to be talking about maximizing capacity, the impact of technology, innovations, and change management on microbiology labs. My name is Rachel Shea. I'm the Associate Marketing Director for BD Kestra Solutions for the U.S. region, and I'll be your moderator for today's event. Today's webinar is brought to you by LabRoots, and it has been sponsored by BD. For more information about BD, please visit our website at bd.com. So I just want to remind everybody before we get started that today's event is interactive, and we do encourage you to participate by submitting as many questions as you want and as you have any time during the presentation. To do so, you just type them into the Ask the Question box and then click on the Send button. If you have trouble seeing or hearing the presentation, click on the Support tab found at the top right of the presentation window, and you can report your question by clicking on the Ask a Question box as well, located on the far left of your screen. I'd like to introduce the presenters for today's webinar. Dr. Erin McElvania is the Director of Clinical Microbiology at North Shore University HealthSystem. Dr. Patrick Murray is our VP of Worldwide Scientific Affairs at BD Life Sciences, and Krešimir Renić is one of our lean healthcare consultants for our Integrated Diagnostic Solutions platform. We're very excited to bring you this session, and without any further ado, I'm going to bring on the first presenter, Dr. Murray.
Very much. It's a pleasure to be here. What I'm going to discuss is some of the microbiology trends, the impact of technology, innovation, and change management. And I'm going to put this in the perspective of during the pandemic that we're confronted with. So let me move to the next slide. And this slide actually is very interesting because we made this about a week ago. And this is the experience with the SARS coronavirus 2 pandemic in the United States. And at that time, 1 week ago, there was 231,000 deaths related to this pandemic. I mention that because every day in the last week, we've approached 2,000 deaths a day. So now this number in 1 week has grown to over 250,000. Likewise, when we look at the number of cases that were confirmed, 1 week ago it was 9.4 million cases. And today it's I'm looking at the exact number, it's 11.6 million. So we have 2 million additional cases in 1 week, which emphasizes how rapidly this pandemic is changing. Let me go to our next slide. And as we think about the impact of the pandemic on the microbiology laboratory specifically, there's a number of things that we've seen an increase. We've seen the development and the performance of diagnostic tests for this pandemic. We've seen an increased demand for swabs, transport media, and testing reagents. And we've seen an increase in molecular testing, not just for the coronavirus, but also for other respiratory pathogens. And finally, there's an increased demand in our technical staff to perform increased numbers of tests that are being ordered and to provide those results in a very rapid time period. We also in the laboratory have seen a decrease. We've seen a decrease in the more traditional microbiology tests that we do, ones for bacteria, for fungi, and for mycobacteria. So the composition of the microbiology laboratory in the last year has changed very dramatically. Now, what I would like to do is also put this in perspective. That means that the microbiology laboratory must reorganize itself to accommodate more work, a different type of work, and to do that in a more efficient way. And so this requires the laboratory to look inward and to try to say, how can we do a better job? And so there's been a number of approaches, manual approaches or more traditional approaches to improving the efficiency of the laboratory. And over the next 2 slides, what I'll do is give some examples of what those improvements might look like. So if we first start with specimen processing, what we see is that as the bottles come into the laboratory, they're accessioned in the laboratory receiving area. We get a collection of the bottles, and then we stand up, walk over to an instrument, and put the bottles into the blood culture incubator. We also see that as specimens come into the laboratory, we batch processing those specimens to make it more efficient. We delay, and many times, unless an incubator is right in the receiving area, we delay incubating those plates after they've been inoculated. And so they may sit at room temperature in the processing area for a number of minutes or maybe even a few hours before we take them into the incubator. We have dedicated individuals that do specialty tests, such as gram stains, because it's more efficient if one person does that versus having multiple people prepare the gram stains and interpret those results. We also might have a dedicated individual that handles incoming phone calls or discussions with physicians about the test that they've ordered. And finally, we typically will process specimens during high volume periods of time where we can keep our technologists busy, but in the off hours, such as in the evening or at nighttime, where there's not very much work to be done, those specimens may sit for a number of hours before they're actually processed for the incubation. That's in the processing area. If we look at how we actually process the cultures, we do the same types of things. We will frequently in the morning go to the incubator, take out the plates that we're going to be working with, put them at the desk where the technologist works, and they may sit there for a number of hours before they're actually processed. Lost that. Sorry. There. We also will batch process a number of specimens, such as a positive blood culture. We'll wait until the cultures are available when they're positive. We may not take them out as they become positive. Rather, we may wait until we have 4, 5, or 6 cultures, take those out, and then we'll do batch processing of those cultures, such as performing a gram stain and identification or susceptibility testing. We have dedicated desks that process different types of specimens. So it's not uncommon to have a blood culture desk, to have a urine culture desk, have a respiratory culture desk, and so forth. We will culture the plates. I'm sorry, I've already mentioned that, where we leave them on the desk. We frequently organize our work based on priorities. So we may process all of the specimens from the ICU patients first, and then process the other types of specimens after that. We typically will organize our identification and susceptibility testing to perform that by batches. So we may read all of our urine plates, indicate what colonies we want to identify, and then once we've sorted the negative plates from the positive plates, we'll go back to those positive plates, select the colonies for identification, and then later perform the susceptibility testing. And then finally, we frequently will only perform work on a primary shift and not be doing the same types of processing in the evening, at nighttime, or on the weekends. And so the work that's performed in the laboratory is done as to maximize the efficiency of the laboratory's processes. Now, let me explore that a little bit more. This was a study that was reported from Europe, where they looked at over 200 laboratories in 25 European countries, and they looked at how they processed blood cultures. And what they found was that in 42% of the laboratories, they incubated the bottles upon receipt 24 hours a day, 7 days a week. In other words, in more than half of the laboratories, we would have bottles that frequently would sit for many hours before they were placed into the incubator. When you look at processing the positive cultures, only 13% of the laboratories would process those cultures immediately. For the vast majority then, they would sit in the incubator until at some point they were removed and processed in batches. 15% of the laboratories didn't process the blood cultures, the positive blood cultures, on Sundays or holidays. And finally, fewer than 5% reported results 24 hours a day, 7 days a week. So again, significant delays in reporting and processing and reporting what we would consider the most significant specimens received in the laboratory. This is a separate study that was performed in the United States, and what we did is we looked at 13 hospitals over an 18-month period of time, and we looked at how they processed blood cultures. There was 165,000 blood cultures received during this 18-month period, and over 15,000 positive cultures. What we observed was that, on average, between the time the specimen was collected until the gram stain was performed, there is a 20.4-hour period of time. If you think about it, on average, it takes between 10 and 13 hours for an organism to grow in a blood culture bottle in a, this thing keeps jumping ahead for me. Between 10 and 13 hours for an organism to grow in a bottle. So there's roughly an 8 to 10 hour delay that we observed with this study. The time from when it was collected until we had an identification of an organism was an additional 24 hours. And for susceptibility tests, it was a further additional 24 hours. So one day to do an identification, when today we have multi-top that can identify organisms in less than an hour from a positive blood culture, and 2 days to get a susceptibility test result. And again, we have systems that allow you to have results in 8 to 12 hours. So why are there these delays? As we look at this more critically, what we found was that, and we'll focus first on the upper left-hand graph, and you see 4 bars. And those are when the blood cultures were collected. And what you see is that it's divided up in 6-hour increments. So the first bar is between midnight to 6 in the morning. The second bar is from 6 in the morning till noon. The third bar is from noon to 6 in the afternoon. And the last bar is from 6 in the afternoon to midnight. You see that bottles are collected throughout the day, night, and evening. And you see this distribution here, with the majority of the bottles collected between, say, 6 in the morning and 6 in the afternoon. Now, if all things were perfect, you would see a similar distribution for the gram stain, for the identification, and for the susceptibility test. The time periods would shift, but the distribution would look the same. In fact, that's not the case. When you look at gram stains and we look at the lower right-hand box, you see about 50% of the gram stains were reported between 6 in the morning and noon. Even more startling, when you look at the reports for identification in the upper left-hand box, or for susceptibility tests in the lower right-hand box, what you see is the majority of the tests, over 80%, are reported between 6 in the morning and noon. More appropriate, more relevant, if we look at a very small time interval, the vast majority, these are reported between 8 in the morning and 10 in the morning. In other words, the microbiology laboratory organizes its work based on its convenience, not when the results should be reported or could be reported. Now, if we look at a different way to improve efficiency and think about automation, there's some things that we can do. You can, instead of having a significant delay in getting the blood culture bottles to the laboratory and put into an incubator, you can put the incubator where the cultures are collected. The majority of the cultures are collected in the emergency department or in the ICU. So there's an opportunity to eliminate the significant delays in transport by just simply placement of an incubator in the area where the cultures are being collected. With automation, you can process specimens as they arrive in the laboratory. They don't have to be batched. There's not a need for that. You can get improved and consistent plate streaking with automation, which decreases the number of subcultures that are required, which will increase, or which will decrease the delays in getting results, getting specimens processed. Because the automated systems have track-based systems that allow you to move the plates from inoculation to incubators, you eliminate the delay in incubation. And then you have now, because of automation and processing, you have reduced staffing needs. So those staff now can be doing other things, such as making telephone calls or performing specialty tests. And then finally, processing can be automated, so skilled technologists aren't required 24 hours a day, 7 days a week. So this allows to have processing throughout all shifts in the laboratory. Just to give a couple of examples of the impact of this, if we think about streaking and we look at a zigzag pattern of automated streaking versus manual streaking, this was a study that looked at the impact with screening plates for MRSA and CRE. And what they found was that the number of subcultures required were significantly reduced with the automated zigzag pattern of streaking. They also found that the time to results was significantly reduced with this because there were fewer subcultures that were required. As we think about then automation as a way to improve processing, we also have to think about its impact on processing cultures. And what you see is that there's a decreased staffing demands, so that the potential for on-demand processing of positive blood cultures, that is the immediate removal of the bottles from the incubator, the performance of the gram stain, the identification and susceptibility testing becomes much more feasible because you now have additional technologists available to do these types of processes. We also, because you leave the plates in the incubator, they're immediately incubated and they're not removed from the incubator during the workup of those cultures. You have faster growth in this constant incubation temperature, and so you can see earlier time to when you have significant growth where you can do your identification and your susceptibility testing. And you can also automate this process of selecting colonies and processing those colonies for identification and for susceptibility testing. And then finally, we have analytics that allow us to guide how the staff is working, where staffing is available to help other members of the staff with their processing. And so we're able to run a much more efficient laboratory with the access of these types of analytics. Just a couple of I'll use one example here just to illustrate the
It looks like we've lost. Dr. Murray. So let me just jump in, and if I could just get some verification in the chat that you could hear me. Not sure if it's us. In any case, yeah, my name is Krešimir. My role with BD is as a lean healthcare consultant, and one of the things that that we like to do is we like to provide like to provide services to lab automation customers. Essentially, not just providing you with an instrument with a piece of technology. The technology is very important. Let's not kid ourselves about that. But really, what we're here to do is provide the value and maximize the value of the automation technology to the lab. What we try and do is really just create a suite of services. When you purchase BD automated technology, it's not just about the install. That's the project management side, the physical and the logistical side of that. But more importantly is the change management part, which Dr. McElvania is going to talk about after I'm done, and then the workflow analysis that we provide to the lab staff and to hospital leadership to understand exactly how that technology is best used and what the impact is both on the lab staff, the wider hospital, and ultimately the patient. Right, so. What we wanted to do was really just, sort of just to disambiguate. When we talk about lean, we're not just talking about cutting headcount. That's really not the goal of any of what we do. We're not, there to compare one shift to another, or just to strictly say, okay, here's what the impact of our technology is, and here's how it will impact, the economics of your lab. That's all important, and again, we're not dismissing that. What we try and do is take an approach, sort of a partner approach with BD customers and Kestra customers in order to understand lab activity and the capability of the staff working there, but also to leverage I guess the repeatability that automation offers in order to standardize work, that human element of work that's involved in automating, and then really just increasing the value of the value created for the patient and for the health system of the lab effort. We have people that work in labs, 24 hours processing specimens. A lot of that repetitive work can be taken away, and we can leverage that knowledge aspect and that decision making aspect that they do offer on in the lab. So when one of the first things that we look at is productivity, right? So just to define productivity, and for any of you engineers out there, there's an equation there, but really simply put, productivity is just the units of production over the units of input, right? And it's really meant as a high level assessment of where how productive we are and how much work we can accomplish with the given input resources, right? So one of the things that we typically look at prior to automation is something we call the LPI, the Lab Productivity Index. There's a lot of misunderstanding about the Lab Productivity Index, what it is, what it isn't. It's not a judgment of where your lab stands relative to others. It's a valid comparator. But it's always got to be placed in context, right? So what we use it for is really just to measure and assess the impact of automation on the overall productivity of the lab. So when we take a look at your lab prior to automation, we'll try and assess LPI and the LPI impact of automation before and after, by measuring the specimens processed in scope. So anything that we think that eventually we can process with Kestra automation, and taking a look at the overall lab staff, the available technologist labor in the lab. And what that allows us to do is really create sort of a baseline measurement. It doesn't tell us all of the issues. It doesn't identify root causes. What it does is really just give us sort of a baseline to compare progress to, right? So we're going to talk about 3 sites that we've engaged in the last couple of years in automating. Now, all of these three sites sort of started from the same place. If you look at the overall in-scope volume, and again, we're not talking about, when we're talking about in-scope volume, obviously we're not talking about chemistry, we're just talking about micro specimens that are destined for or able to be processed on Kiestra lab automation. So we're looking at, volumes of anywhere between 425 or 375 rather to about 450. That's all in the same ballpark, right? And the reason we're showing you this is not necessarily to talk about the details of these three labs. It's just to sort of, to gauge them one against another. We're not talking about a massive reference laboratory that's processing thousands of specimens a day. These are three sites in with three different population centers, and three different really sets of circumstances, but from let's say a very high level. So again, that LPI level, that number of specimens processed on a peak day, they're relatively the same. But one of the things that we identified prior to this, and in engaging the customers, the level of staff engagement, the level of leadership support, and that disposition to change, right? Change management is something Dr. McElvania will talk about in a little bit, but all of those for what we call Site 1 were relatively low, right? Whereas the other two sites were a lot more engaged. They were they were in a better position, let's say, to manage that change and to manage the processes involved in lab automation. And what we saw, and you'll see that on the next slide, is the difference that outcome has in overall lab productivity, right? So if we look at Site 1, where we said the level of engagement, that resistance to change was higher, staff was less engaged, leadership was sort of less willing to really adapt the way they were working, and really trying to hold on to that pre-automation sort of paradigm. You see them starting at a level of at an LPI of around 17 and going up to 48.8%. By any definition, that's an amazing increase in productivity, right? That there is really the selling feature of the technology in and of itself. It's just saying, look, if you really do, if you really adopt automation, it's going to increase your productivity. It's going to take away some of the repetitive and let's say the more mechanical aspects of the work in the lab, so that your staff can really focus on the analytical and the intelligence side of what we do in a lab. But when you compare it to the other two labs where staff was more apt to change, where, as a team, they were more willing to adapt standard ways of working, sharing work, right? Lowering batch sizes, moving towards that ideal of one patient at a time treatment. You see that there's a significant increase and a significantly better improvement in that overall lab productivity. And really, that's all we're saying, is not saying that these three labs are identical, and what was done in Site 1 should be a warning sign. It's really just, here's the opportunity, right? The opportunity is, one, let's use that automation as a platform for a larger change in the way we process specimens in the lab, in the way we deal with patients as they present themselves at the lab in the form of a specimen, and change the way that we work, change the workflow, change the way that we distribute work and share work from one bench to another, but also from across shifts and that sort of thing. And one of the things that Kiestra technology allows us to do, and this is just one very simple example, is the level of information that we have, because of the fact that all of our engagement with specimens, with automated specimens, is recorded. It allows us, in great detail and specificity, to take a look at, well, what are some of those metrics? In this case, this is just an example. This is not meant to be indicative of where your lab ought to be. It's just really saying, here's what we're able to do is to say that, okay, well, the site that we refer to as site 1, their reads per plate and the number of times that they were looking at a particular plate once it was incubated is significantly higher than the other two. And what we realized afterwards in digging into that process is there were some elements of the population, the specimen types that contributed to that, but in a lot of cases it was the way they distributed their sample. It was the way that they approached cross training and staffing on different benches, and we were able to coach them towards an improved situation, an improved current state where that gap is significantly lower than what you see here, right? And really that's the benefit that we're trying to demonstrate is how do we leverage technology? How do we change the workflow and change the way we engage with that automation technology in the lab? And use the informatics that Kiestra allows us to pull. How do we use that to really improve and continuously sort of go back to the process and continue to engage staff to change and improve the way that we're working on things. So, one of the words I've been using a lot has been change, right? And that psychological aspect of changing the way we work. I'm going to hand it over to Dr. Erin McElvania, and she'll talk to you about the change management and that human and psychological management aspect of actually adopting technology and Kiestra technology and automation in the lab at North Shore. So go ahead, Dr. Erin.
Hello, and I want to thank BD for asking me to speak to you today, and I'm really excited to talk about something I'm passionate about, which is total laboratory automation, and also just what happens to an actual lab when you undergo this huge transition. So just for, I guess, to baseline you, I wanted to introduce my hospital system where I'm at. So North Shore University Health System is located in the North Chicago suburbs. And you can see on this map here, each one of these dots is a hospital we have. We have 4 legacy hospitals that our microbiology lab currently serves. Plus, we have recently acquired 2 additional hospitals and are in talks about bringing that work into microbiology possibly. We also have a large outpatient reach with over 25 immediate cares, over 100 physician offices, and all of the microbiology for the whole system is centralized in Evanston, Illinois. And just to also baseline you, we do about 344 billable tests. That's for last year. This year, remains to be seen. So I wanted to show you our lab before we got Kiestra TLA, and you can see that it looks like, a very normal microbiology lab, but very cluttered, a lot of things in a small space. And it was important for us to stay in the same space. We really liked where we were located in the hospital, and the access it gave us to our physicians. So for that reason, we wanted to stay, and this is kind of what we look like during our physical transformation to Kiestra, and this is what we look like afterwards. So standing in the same spot in the picture on the left, you can see how open and decluttered, and just I always say it's a little bit zen, which is odd for a microbiology lab. But those are the physical changes, and what I think everyone understands when they get TLA, there's going to be a big physical change in the lab. But I don't think everyone recognizes that there are a lot of culture changes as well. And I think those are just as important as physically getting the Kiestra, be able to use it to its maximum capacity. So the workflow change is that before Kiestra TLA, we had very defined benches, as Dr. Murray mentioned. You got your urine bench, your respiratory bench, et cetera. And at the beginning of the day, you go to the incubator, you get your plates for that bench you're working, you set them down, you start working through them, work till lunch, put them away, bring them back out, work in the afternoon. At the beginning of the day exactly what you have, and those are your cultures, and you are manually viewing all of those agar plates. So the big change for us is when we got Kiestra TLA, we moved from individual specimen benches to a model that's collective and consists of a reader bench and a worker bench. So what that consists of, as you can see here, this is our reader bench. It is not connected to our Kiestra TLA system. It could be anywhere in the lab, in the hospital, on a beach, etc. after COVID. So what happens at this bench is you can see our wonderful technologist Barb here. She's viewing our LIS system, our internal laboratory information system on the left, and Kiestra plates on the plate images on the right. And she's going to read through these plates and decide, you know, does something need further workup? Is there no growth? Is it mixed? And she's going to do all of that while viewing the plates on the computer and not physically handling any of the plates. And so for this whole time, the Kiestra plates are being read. They're in the incubator, warm, nice CO2 concentration, happily growing bacteria as quickly as possible. And so for this, it is really collaborative reading of cultures, because you have all the cultures that need to be read that day are on a common work list, and then all the people assigned to the reader bench are just going to work through those through the course of the day. Now, in contrast, then we have our worker bench. And so these are the benches that are attached to our Kiestra TLA system, which is to the left of another one of our wonderful technologists, Adil. And here, plates are going to, anything that needs to be worked up is going to be handled on this bench. If you need a catalase, if you need to perform MALDI-TOF mass spectrometry identification, if you need susceptibility testing, anything where you physically handle those plates, they are going to be pulled out of the incubator and delivered to the bench by a track. So the technologist does not have to get up and go find them. And again, you're only pulling out the plates you absolutely need. You don't pull out all the plates associated with a culture. And so this also just maximizes the time those plates are in the incubator, and also decreases a lot of clutter, because you're only pulling plates out for a few minutes and then putting them back on the track so they go back into the incubator. So as you can see with this method, instead of these plates are mine, and I am going to work on them till I'm done at the end of the day. It's more of a change to no one is done till everyone is done. All the cultures are collectively owned. They are read and worked up in a, I won't say a random fashion, but they really do belong to everyone. And so this is really nice because it establishes a protocol. It keeps us on our protocols, because at least 2 sets of eyes are in each culture, both the readers and the workers. And it also, that results in strict adherence to laboratory protocols. There you go. And it also allows for a lot of flexibility between the readers and the workers to really optimize that productivity on the specimen workload. So my example is always that if you come in early and you happen to be on a worker bench and there's no work for you to do, it doesn't matter. You can easily move back and forth between the benches. And so you will take up a reading, you will take up the reader bench and read a few cultures to make some work for yourself. And then as your colleagues trickle in, if you're the first person in the morning, then you will be able to make that work. And then at the end of the day, kind of conversely, that the people will have more work to do because all the cultures have been read, and so they will help out with testing and susceptibility, things like that, on the worker bench. So this really allows for better staffing efficiency. What you can do with this system with the readers and the workers is you can really look at when do your specimens arrive to the lab, and how can I optimize both my staffing work times and then also my reading time, how long a plate is incubated before you take an image of it, based on the type of specimen it is, and also your volumes and your arrival times. And we have this all tracked on a nice dashboard. And so that you can look at the dashboard, you can come in the morning, you see how many cultures need to be read and the breakdown of what kind of specimens they are. You start your most important specimens like your blood, CSF, and kind of move along throughout the day. And you can even base what is going on in the afternoon, say, you know how many cultures are coming up to be read, and so you can plan around that. Okay, so change management is difficult. I don't want to say that it's not. And how does staff actually respond to such a drastic culture change? And the answer is there's not one answer. Like people, it is variable. There are definitely going to be some staff who are just not interested in going on this journey and may go to different areas of the lab. We have some staff that adapt very, very quickly. And then we have all kinds of staff in the middle. And so, you know, it's a range for sure. So what can you do to make this culture change better? One thing I would say is very careful selection of a key user group. So this is our key user group here from when we went live with TLA. And what they are going to be is your champions of automation. They are going to get you through this process, and they are going to bring the rest of the staff along with them. They're going to need to have a positive attitude and really believe in automation as the future for this to work out. And so in our group, we picked a variety of people from all three shifts so that every shift was represented, and then, you know, they're able to help along that journey with everyone involved. You also need really strong leadership. There will be some hard days, I am not going to lie. And so for that reason, you need a lab director, you need administration, you need everyone involved to really believe that this is the future and kind of have the attitude going forward. We can't get bogged down in little things. We have to make sure we're moving forward and optimizing for the future. So what I think was most useful for us in surviving this culture change is really communicating a lot with your technologist. So I say that although, you know, I hear a lot more from administration and the physicians being a laboratory director, my technologists are in constant communication with each other. They see the calls coming in that they're getting. They notice areas for improvement, definitely, and many processes that I'm just not going to pick up. So we have constant communication about areas where we can improve. We also, you got to embrace a lot of creative ideas. And I have to say some of the best things that have come out of this have been ideas that some of our technologists had for how we could do things a little bit differently than we had before. And they ended up being very efficient and it worked very well for everyone. And I really do think it's the participation of everyone involved in the whole automation process that leads to ownership of the process and then acceptance, because it's not something else that someone's forcing on them. It's their process. They're responsible for making it be the best it can be. And so, although, you know, at this point, when we first got our TLA, I will say that, you know, there were a lot of things to work out because we were the first one in the nation. And so we were working together with BD to get a lot of things ironed out. And now we're pretty much set in our protocols, but that doesn't mean we're done. It's just like all laboratory protocols. You're always looking for gains in efficiency, little tweaks that you can make to make things easier on the lab, to shave a little bit off your turnaround time. And then we're constantly adapting because even, you know, outside the lab, as evident with COVID-19, there's a lot going on and you have to adapt to those changes. So for example, our courier schedule got changed, had a drastic redo a few years ago. And then that caused us to look at all of when our specimens were coming into our lab and kind of reassess the best times for our cultures and our staffing hours. So we know that there is a huge staffing shortage in microbiology. This is from 2015, but things have not gotten better since then. And we also know that there's a high rate of anticipated retirement. So I think only all laboratorians know this, but now it's kind of becoming evident to the rest of the world that that laboratory medicine staffing is something that is of great concern. So what can you do to make the staff, to minimize those staffing shortages? Well, I would say that automation definitely would be one thing that I would do if I didn't already have it. So I wanted to look a little bit up. So I looked into a little bit of return on investment. How are we doing with our Kiestra TLA now that we've had it in use for about 5 years? We went live in December 2014, so I guess it's almost 6 years. And at that time, we had about 26 full-time employees, full-time equivalents, probably a few more employees. So in the past 5 years since we've had Kiestra, our volumes before COVID they had grown by 21%, and currently we have 21 and a half full-time FTEs. So that shows that we are doing a lot more, we're handling a lot more volume with less people. So this is just a picture today. This is a typical day staff that we have in my lab, and actually there are 3 med tech students in there as well. So we're pretty lean. So looking at our volumes, with that 21% increase, we would have needed, if we were doing our pre-COVID, our pre-Kiestra, we had our pre-Kiestra setup, our plate reading, our lab, we would need 31 and a half FTE to handle that increased workload. And I know I showed you pictures at the beginning, but there was not room for an additional 5 or 6 full-time employees in that space. We were very crowded before Kiestra was implemented. So that 10 extra FTEs would cost our department, this is conservatively, way over $750,000 a year. We also would not fit in our current laboratory space, as I said, so we'd have to look at, are we going to move? What are we going to do? There is no additional space in the hospital, so it would have been very costly. And then we could never have entertained adding the workload of 2 additional hospitals onto our current volumes without automation. And that is just what we can measure in the lab. There are a lot of financial benefits that are indirectly, indirectly related to the lab, and therefore they're a little bit difficult to assign costs. But we're definitely using fewer laboratory supplies. We're doing fewer subcultures, fewer loops, fewer, just a lot fewer things in the lab. For our patients, they're more rapid hospital discharges, we believe, based on the rapid nature of which we're getting our identification and susceptibility results out to physicians, and then also using fewer antibiotics and fewer doses of antibiotics, which are very expensive as well. So the benefits go outside of the lab, but those can be a little bit more difficult to quantify. So in conclusion, I just want to say that implementation of BD Kiestra, it requires a completely different workflow than traditional microbiology, but I really think it's worth making the change, because just dropping, as Kresh showed, just dropping the Kiestra in a lab does make it somewhat more efficient. But if you're able to change the culture of the lab and really optimize, you're able to increase that efficiency dramatically. Change management is challenging, but with strong leadership, both from, I would say, all the way from the top administration, lab administration, laboratory directors, and staff and the technologists, you can get through it. And like I said, definitely worth the pain to go through. And the return on investment really is there for TLA. You can see that just in the staffing efficiencies alone, let alone other benefits to the hospital. So with that, like I said, I just want to thank BD for asking me to speak today. And I think we will move on to the Q&A portion of this presentation.
Thank you, Dr. McElvania. So we do have some questions here. And I just want to remind everyone who's on the line, if you have a question that you would like to ask, just add it into the Q&A, the Ask a Question chat box. So the first question that I have here is from Kress. It's for Kress, I should say. So what kind of workflow data is available from the Keystra systems, and how do labs tend to use this in order to improve their processes?
Well, first off, what Keystra allows us to do, in the first generation with a daily report, and now with the upcoming generation of Keystra and Synapsys, it really allows us to take a detailed look at everything that happens on the actual system, with taking a look at in terms of what's being processed, the number of specimens of each different kind. It allows us to break that sort of thing down and really give us a picture of what's actually coming through the lab. Secondly, it allows us to take a look at the we can pull information from the system that allows us to sort of give us a life cycle of each and every specimen, to take a look at when something was inoculated, when it was incubated, when was it followed up, and what that sort of time, that cadence is. How long was something, how long was a specimen or a plate ready for reading, and when was it actually read, right? So that's useful in sort of helping us compress that delta T and really stay on top of I guess just the mechanics and the day-to-day processes that happen in the lab. It allows us to take a look at who is doing what and how long was how much effort we're putting in different areas of the actual of that specimen life cycle. So really what it allows us to do is at a very very detailed level, it allows us to analyze the basic mechanics, the operational efficiency of the lab staff, and of the work that's going through. And it allows us, it doesn't tell us how well we're doing. It really just points us to ask questions, right? So, looking at one report and one snapshot of a single day doesn't tell us anything if we don't follow and do that daily management aspect of lab management. So once we see that something is sort of off off the charts in terms of either it's a particular specimen type was really either a lot slower than or a lot faster than usual, or we spent a lot more time working up specimens, it allows us to follow up with those questions, right? So again, it's not about the technology and what's happening, it's about how we use the information that we get from the technology in order to make informed decisions about the lab. I hope that answers the question.
Yeah, no, that was perfect. Thank you, Kress. Question here for Dr. McElvania. So for hospitals or labs looking to understand the financial impact of lab automation outside of the lab, what approaches would you recommend that they take a look at?
So I guess what is the perspective of this question? Is it someone looking to bring in automation as, for administrators? Is it a lab director? Is it, I think it kind of depends, but it is very hard to capture costs outside of the lab, I will say. And so, although we've worked somewhat to find the answer to this, you need a really strong data management system, like your electronic medical record, to be able to track, everything that's going on. So, it's challenging. We know it's there. We hear from our colleagues. We hear from pharmacy that they appreciate having the susceptibility testing so quickly. I know when we went live, Dr. Thompson, who was here previously, said someone called the lab and said, there must be a mistake. We just sent this urine down, and because we had a read on it in 10 hours, like probably 10 and a half, got to do some testing. But we had to read so early that someone thought we had a specimen mismatch. That was right before we went live. And we're like, no, that's your patient's specimen. Like, we have this new system, and it's just very fast. So we definitely know the impact does, reach the clinicians, and but we just don't always have a great way to measure that.
Yeah, no, that's very fair. So another question here, and maybe this is one that I'll ask Dr. McElvania first, but then Chris, maybe you can also give sort of a higher level perspective as well. So it's more around, have we reviewed turnaround times from collection to when the specimens are received in the lab to time to result before and after automation, and what kind of improvements we're seeing? So maybe Dr. McElvania, if you could give the North Shore perspective first, that would be great.
Yes, I mean, for me, I have to think back because it's been a while since we went through this transition, but definitely when we looked at our turnaround time, and I think Dr. Thompson did publish on this with urines, I mean, we saw a dramatic decrease in our turnaround time for urine. And then also because we were getting the ID sooner, we were getting susceptibility testing set up sooner. So even though susceptibility testing itself was not shortened, we were starting the process sooner. Therefore, the final result was out sooner. So all the way around, definitely it has a huge impact. We picked urine because that's what we had the most of, and it's it's probably one of our easiest things to measure, but this is affecting all specimen types that we have.
So the thing that I'd add to that is Rachel, you mentioned that delta T between turnaround time between collection and result. So that actually requires us to look outside the walls of the lab. What we found is that that's sometimes a profound sort of mindset shift for a lot of labs to really look at what happens outside the lab. It does require us to monitor the data, but typically what we find is that when you start monitoring something, it does decrease. Not just magically, it's because, when we start monitoring it, we actually make an effort to begin to ask questions. That's one of the powerful things about automation, is the data that it gives us allows us to ask questions that will attack those sorts of things. So turnaround time doesn't magically decrease because we automate, but there's a concerted effort to understand the system and the process, and that's something that as a healthcare consultant with BD, we do help labs actually work towards that asking those questions, taking a look at the data, and not just saying, well, here's your scorecard. Is what does that actually mean? Spending time in the lab, taking a look at what's actually going on, and what does this metric mean? How do we slightly change our behavior in the lab and our workflow in order to maybe reduce that time, right? Reduce some of those delays in between one step, both prior to automation and afterwards. One of the things that we're looking at is mapping that out. That's an ongoing initiative to actually map out that collection to result workflow. But yeah, really there is a reduction there. But again, it's not. It doesn't just happen because we flick the switch on the Keystra. It has to be managed, and it's important to stay on top of that.
Yeah, and I would just, I know we're short on time, but I would just piggyback on Chris's answer in that I completely agree. It allowed us to, Keystra allowed us to really look at when our specimens are coming in, when they're ready to be read, and to see if we could change our staffing by just a little bit to be able to capture a large percentage of those organisms. Whereas sometimes, if a slight change in staffing is only resulted in reading an extra 3% of cultures, that's not worth it. But maybe an hour or two could get you 30% of cultures or 20%. That would be a staffing change you'd want to make potentially. And so I think it's really good to be able to track that, because not all shifts are created equally. So completely agree.
Great, thanks. So again, as you mentioned, we're sort of at the end of our time. So I just want to thank everybody. We do have more questions coming in. What I will do is I will provide the questions to the speakers and have them provide a response so that, again, don't feel like your question won't get answered, because I think there's a lot of really cool questions here. Obviously, this is a really interesting topic. So again, I wanted to thank our presenters for joining us today, sharing their experiences, and thank you all for attending. We really appreciate your support.
Thank you for
Thanks,
having us.
everybody.
Great, thank you, everyone.